The world was reeling from the Cuban Missile Crisis when it had come closer than ever to a nuclear conflict between the US and the Soviet Union. Both the US and the Soviets launched high-altitude nuclear tests at the edge of space.
Imagine the vast, silent expanse of space, serene, untouched, and infinite. Now picture this tranquility shattered by a man-made explosion, a burst of light and energy more powerful than any natural phenomenon we've ever witnessed. This is not a scene from a science fiction movie. This is history. This is what happened when the US nuked space. To understand why the United States detonated a nuclear bomb in space, we need to rewind to the 1960s, a period marked by the Cold War, a time of intense rivalry between the USA and the Soviet Union. Both superpowers were locked in an arms race, a race not only to dominate the Earth, but also to conquer the final frontier, space. In this high-stakes game of geopolitical chess, space was the ultimate high ground. Control of space meant control of the future. It was within this context that the United States embarked on Operation Fishbowl, a series of high-altitude nuclear tests conducted under the larger umbrella of Operation Dominic. On the night of July 8, 1962, Hawaii witnessed an extraordinary display of auroras. The Honolulu Advertiser had predicted a dazzling spectacle with the headline, "End blast tonight, may be dazzling. Good view likely." At 9 seconds past 11 p.m., an intense flash illuminated the sky, shifting from green to yellow to orange, before settling into a vivid red. This event was the result of the US detonating a thermonuclear bomb, 100 times more powerful than the Hiroshima bomb, launched from Johnston Atoll. The explosion occurred 250 miles above Earth, in low Earth orbit. Known as Starfish Prime, this was part of a series of nuclear tests by the US and Soviet Union from 1958 to 1962, but it was the most significant. The blast caused a power surge over the Pacific, knocking out about 300 streetlights on Oahu and damaging or destroying about a third of the satellites in orbit at the time. The explosion was a spectacle of unparalleled magnitude. For a brief moment, night turned into day as a flash of light illuminated the sky, visible from as far away as Hawaii, 900 miles away from the blast site. But the beauty of this celestial firework masked a darker reality. The immediate effects of the detonation were both awe-inspiring and terrifying. The explosion created an artificial aurora, a rainbow of colors dancing across the sky, resulting from the interaction between the bomb's high-energy particles and the Earth's magnetic field. But beyond the visual spectacle, the detonation had profound implications. It released an electromagnetic pulse, or EMP, powerful enough to knock out electrical systems over a wide area. In Hawaii, streetlights went out, telephone lines went dead, and radio signals were disrupted. This EMP effect was a stark demonstration of the destructive power of nuclear weapons, not just on Earth, but also in space. It highlighted the potential for using nuclear detonations to disable enemy satellites and communication systems, a concept that would shape military strategies for decades. However, the detonation also had unintended consequences. The explosion created a new radiation belt around the Earth, adding to the natural Van Allen belts. This artificial radiation belt posed a significant hazard to satellites and space missions, increasing the risk of radiation damage to both equipment and astronauts. Several satellites were rendered inoperable by the radiation, including the first commercial communications satellite, Telstar. This was a clear indication of how even a single nuclear explosion in space could have far-reaching and unpredictable effects. The Starfish Prime shot is sort of the poster child for why we don't like nukes blowing up in space, says Jonathan McDowell, an astrophysicist at the Center for Astrophysics, Harvard and Smithsonian. Indeed, only a few years later, in 1967, both the US and the Soviet Union signed on to the Outer Space Treaty, which forbade putting weapons of mass destruction in orbit. Looking back, the Starfish Prime test was a pivotal moment in our understanding of the dangers and complexities of space. It underscored the need for international agreements to prevent the weaponization of space and the potential for catastrophic consequences. Now, some 6 decades after the last nuclear detonation in Earth orbit, the threat of another has emerged with the Department of Defense, warning about a potential Russian program to place a nuke in space. When the United Nations Security Council recently put forward a resolution to reaffirm the ban on such weapons, Russia vetoed the measure. US officials have said there is no imminent threat because no warheads are known to be in space. But they have deemed the prospect deeply troubling because a nuclear detonation there today would be far more destructive than even Starfish Prime. On Earth, a nuclear explosion follows a well-documented catastrophic chronology. There's the initial fireball itself, which can vaporize or burn everything in a wide radius. Then, there's the shock wave from the sudden change in air pressure, which can level buildings and ignite firestorms. And finally, there's the distinctive mushroom-shaped cloud formed from these effects and the associated atmospheric fallout of deadly radioactive material, which can kill in a matter of minutes or decades. In space, though, it's a different story. There's no fireball, shockwave, or mushroom cloud. Instead, the explosion releases its energy as electromagnetic radiation, including gamma rays and X-rays. This results in 3 waves of destruction. Then there's the electromagnetic pulse, or EMP. X-rays from the explosion collide with atoms in the upper atmosphere and release electrons through a process called Compton scattering. These electrons, along with other charged particles from the explosion, run along the lines of Earth's magnetic field, causing some of the spectacular auroras witnessed across the Pacific during the Starship Prime test. Depending on a nuclear explosion's size and altitude, its EMP can wreak havoc on the ground and in orbit, potentially damaging or disrupting unprotected electronics in spacecraft and in devices across a large swath of Earth's surface. First, a brilliant flash of light disables satellites within its line of sight. Next, the electromagnetic pulse, EMP, causes havoc by releasing electrons through Compton scattering. But the third wave is the most devastating, a lasting belt of high radiation, similar to the Van Allen belts. This radiation can linger for years, shortening the lifespans of satellites. For instance, the Starfish Prime test in 1962 created a radiation belt that damaged or destroyed many satellites, including Telstar, which failed months after launch due to radiation exposure. With nearly 10,000 satellites in orbit today, the impact of such an event would be catastrophic. Critical systems like GPS satellites and SpaceX's Starlink network could be compromised, and astronauts on the ISS and China's Tiangong habitat might be at risk. An EMP could knock out essential electronics, leaving crews vulnerable and exposed to lethal radiation. Even though shielding can protect electronics and Earth's atmosphere blocks harmful radiation from reaching the ground, an orbital nuclear blast could escalate global tensions and potentially trigger a thermonuclear war. While it's uncertain if Russia is seriously pursuing space-based nukes, the US government is taking the threat seriously. Russia's influence in space has declined since the Cold War, but it remains a leader in counter-space weapons and operations. However, destroying satellites would be a major escalation and a significant red line to cross. The stakes are high, and the consequences could be dire for everyone on the planet. Today, space is largely seen as a domain for peaceful exploration and scientific discovery. But the memory of Starfish Prime serves as a reminder of a time when the darkness of the Cold War cast a shadow even in the heavens. As we venture further into space, seeking to explore and understand our universe, it's crucial to remember the lessons of the past. The story of when the US nuked space is not just a tale of scientific curiosity and military ambition. It's a cautionary tale about the fragility of our world and the need for responsible stewardship of the cosmos. This has been a journey through one of the most dramatic and lesser-known episodes of the Cold War. Thank you for joining us. Until next time, keep looking up, and remember, the history of space is a story still being written.